Rock crushers are brawny machines designed to smash big boulders to bits. The broken rock is then used to make asphalt pavement, concrete building foundations, ceramic tile, and many other things. Modern society is largely built on the crushing strength of these powerful machines. If there's one invention that's been a smashing success, it's the rock crusher. These machines are designed to pulverize. This crusher slams rocks against anvils to shatter them along natural stress lines. They break into uniform cubical particles that can be processed into many different things. Production starts with the crusher's lid. A computer-controlled plasma torch cuts through a sheet of steel that's underwater. The water keeps the smoke down as the plasma gas makes a sharp, precise cut. They feed a piece of steel back and forth between rollers to shape it into the crusher body. With each pass, the strip curls a little more. When the two ends meet, the steel is sufficiently cylindrical. The technician tack welds the ends while the steel is still in the rolling machine. This holds the shape so that he can then do a complete weld. After a bit more work, the crusher body is ready for mounting to the base frame. They lower it into place with a crane and weld it to the section that will hold the electric motor and pedestal. After a paint job and some fittings, the focus turns to the inside of the rock crusher. A worker bolts steel castings to the interior wall. The rugged castings will protect the crusher structure from damage, as rocks are slammed around inside during crushing. He secures the bolts from the outside of the crusher structure. They're now ready to assemble the crusher bearing and shaft. The worker starts with the bearing. He carefully aims a torch at it, and the exposure to the steady flame causes the bearing to expand. When it's large enough, he lowers the shaft into the bearing. As the bearing cools, it shrinks to the shaft for a tight fit. This takes several hours. Then he heats the opening in a part known as the pedestal housing to enlarge it. He inserts the shaft and bearing assembly into it. The housing cools and shrinks to the bearing. They also equip the other end of the shaft with a bearing and cap, and then it's time for a test run. They run each pedestal unit for 2 hours, so a computer can thoroughly assess its performance. The pedestal shaft assembly has passed a gamut of tests. It's ready to go into the crusher. The installer bolts it to the frame in 6 places. He attaches it to the protruding shaft bearing by heat shrinking it in place. He reinforces the installation with 2 lock nuts. Meanwhile, a robot welds brackets onto a machined steel plate that will serve as the impeller. The impeller is a kind of turntable that revolves to toss the rock into anvils to shatter it. They attach parts called shoes to the brackets. They transfer the impeller to the crusher and bolt it to the hub. A worker installs chrome and white iron castings. The castings are the anvils. Arranged in a ring, they serve as the striking surface for the rocks. He installs them on an angle and locks them in position. The crane transfers the ring to the crusher, and the anvils now surround the impeller. With all of the components in place, it's time to put the lid on the rock crusher. A worker presses a decal with brand information onto the outside. They install the electric motor, and this crusher is now ready to reduce rocks to rubble.